Welcome back, everyone. In the previous video, I introduced second order differential equation, linear second order differential equation, and I talked about homogeneous equations. You get the point? Homogeneous equations. And we said that a homogeneous differential equation of the second order is of the form a d squared y dx squared plus b dy dx plus cy equal to 0. So we talked about the auxiliary equation and I gave the different forms in which the general solution of that equation will be based on the type of root. So we have the real and different root, real and equal root, and complex root as well. So these three equations fall under the three categories of we have real and different roots, real and equal roots, and here we have complex roots. So I'm going to solve these three differential equations now to explain the concept better. Keep watching. Let's go with the first question that says d squared y dx squared minus 3 dy dx plus 2y equal to 0. So what we have to do first of all is to obtain the auxiliary equation. Okay, so let's go straight to the auxiliary equation without making mention of the d operator form. You get it? So the auxiliary equation is this. In place of dy dx, write m. So here we have m squared minus 3m plus 2 equal to 0. This is the auxiliary equation. Let's solve it. It is a quadratic equation. Okay, so this is 1. 1 times 2 is 2. And here we have minus 3 as the coefficient of m, minus 3. So two numbers that we multiply to give us 2 and we add to give us minus 3. Two numbers. The numbers are minus 2 and minus 1. Check. Minus 2 times minus 1 is plus 2. Minus 2 plus minus 1 is minus 3. So this is it now. We have m squared. In place of minus 3m, we can write minus 2m minus n. Minus 2m minus m plus 2 equal to 0. So let's factorize. We have m. M is common to this first 2. M minus 2. Minus 1 is common to this last 2. Minus 1, we have m minus 2 equal to 0. So m minus 2, then m minus 1 equal to what? 0. So from here, if we set this to 0 and set this to 0, m is equal to 2 or 1. You get it? So these are the roots of the equation. Let's call this one alpha and let's call this one beta. So the roots are real, they are real numbers, and they are not the same, they are not equal, 2 and 1. Remember what I said, if the roots are real and different, the general solution will be of the form y equal to a e to alpha x plus b e to the what? Beta x. Alpha and beta are the roots. So therefore, the solution to this differential equation is this. Y equal to what's alpha? Let's say 2. Alpha can be 2, beta can be 2, anyone. So this is 2x plus what? B e to the power of what? Beta x, and beta is 1. That's x. This is the general solution to this differential equation because the roots are real and different. Let's go ahead to solve this one. Here we have real and equal roots. We are going to see it now. Just keep watching. Remember to hit on the subscribe button, okay? Like this video and share it with your friends and with your classmates as well. D squared y dx squared minus 8 dy dx plus 16y equal to 0. So the auxiliary equation is m squared minus 8m plus 16 equal to 0. Let's solve. We can easily solve this. Okay. This is 1. So 1 times 16 is 16. And this is minus 8. So two numbers that will multiply to give us 16 and add to give us minus 8. So the numbers are minus 4, minus 4. Minus 4 times minus 4 is 16. Minus 4 plus minus 4 is minus 8. So here we have m squared minus 4m minus 4m plus 16 equal to 0. So m, let's factorize this first two. M comes out, we have m minus 4. Then minus 4 will come out. We have m minus 4 also. Equal to what? 0. So m minus 4, m minus 4. This m minus 4 in bracket, I'm taking 1. Then this m minus 4 is what I have here. Equal to what? 0. So if I set them to 0, I'll have m equal to 4 or m equal to 4. That is, m is equal to 4 2 times. So what we can see now is we have two roots, 4, 4, alpha, beta. But in this case now, alpha and beta are the same. So alpha, alpha. So remember the solution to a differential equation whereby we are having the same root for the auxiliary equation. Y equal to e to the power of alpha x into ax plus b. So the general solution to this equation is y equal to e to the power of alpha x. Alpha is 4. 4x into ax plus b. That is it. Let's go to the last one. D square y dx square plus 6 dy dx plus 13y equal to 0. So the auxiliary equation is m squared plus 6m plus 13 equal to 0. This equation is not factorizable. Okay, so let us use the almighty formula, that is the quadratic formula, to determine the roots of this equation. The formula says x equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. But here we are dealing with m, not x, so I want to write m here. Alright, so m is this, minus, what's b? The coefficient of m squared here is a, and it is 1. Here, the coefficient of m is 6, and this is b. This is a, this is b, and 13 here is a constant, that is c. So b is 6 plus 6. That's 6 squared minus 4 into, what's a? 1. And what's c? 13. All divided by 2a. A is 1, so 2 times 1 is 2. Okay, so we have this. M equal to minus 6 plus or minus the square root of 36 minus 4 times 13 is 52. All over 2. Okay, so we have this. M equal to minus 6 plus or minus 36 minus 52 is minus 16. Minus 16. So that we're having this. Minus 6 plus or minus the square root of minus 16 will produce a complex number, that is 4i or i4. Let's say i4. Okay, because this is if you take the square root of a negative number, you are going to obtain a complex number. So divided by what? 2. So we can say this is m equal to, okay, minus 6 over 2 plus or minus I4 all over 2. So m is minus 3 plus or minus I2. Yes, this is it. So the root now of this auxiliary equation is this. M equal to minus 3 plus I2 or m equal to minus 3 minus I2. These are the roots. But remember that if the auxiliary equation has the solution m equal to alpha plus or minus I beta, okay, which is actually a complex root, the equation will be of the form y equal to e to the power of alpha x into a cos beta x plus b sine beta x. This is the general solution to the equation, whereby the auxiliary equation has this complex root. So the general solution to this differential equation is this: y equal to e to the power of, what's alpha? Alpha is minus 3x into a is a constant, cos beta, what's beta? 2x plus b sine beta x, that's sine 2x. This is it for this very equation. I hope you enjoyed the video. Keep supporting by subscribing to this channel, like and share this video to your friends and to your classmates. I'll see you in the next one. Keep following.